to our simple guide on how to assemble your new bike. In this video, we will walk you through the assembly process and all the necessary adjustments to get your bike road ready. We'll also explain important safety information and provide direction and tips for building a bike with the tools you have at home. Some specialty tools may be required for the assembly, which may only be available in a store. When building a bike for the first time, it's important to review your warranty pamphlet, your owner's manual, take your time to complete the bike build, and follow all safety advice. This video should be only used as a resource to support you in assembling your bike, but does not provide the full scope of training for assembly. If you have any questions or run into any challenges, please contact Sport Chek customer service. Before getting started, you will need to grab a few tools. You may not use all of them for your specific bike, but these should help you with most of the bikes we sell. Place the bike right side up and open the box using box cutters. If you don't have a box cutter, open the box by pulling up on the cardboard flap while being cautious of the staples. Lift the bike out of the box and place the bike on the ground. You can lean the bike against your box to protect your bike and your walls or furniture. Locate the owner's manual and your accessories box with the small parts. Review your owner's manual thoroughly, as your bike might have slightly different componentry than discussed in this video, requiring a technician to complete these services. Unpack your accessories box to find items like your quick release skewer, your reflectors, your pedals, and any other specific items for your bike. You may not have all of these items with your specific bike, so don't panic if you can't find them. Using your snips or strong scissors, cut the zip ties and remove the loose items from the bike, like the seat post and front wheel. Continue to remove all of the packaging from the bike and recycle or dispose of these parts appropriately. As you do this, inspect your bike and look for any damage. If all looks good, let's proceed to the next steps. The first thing we are going to install is the rear red reflector using the number 2 Phillips screwdriver. It will need to go in an upward position a few centimeters below the saddle so that it is visible and can reflect light correctly. Tighten the reflector so it stays secure. Apply a small amount of grease to the inside of the seat tube. On all seat posts, you will find inscribed lines that will indicate the minimum insertion point of your seat post. The top of this line needs to be below the top of your seat tube on the bike, as seen here. Next, you want to secure the seat post with a quick release. This needs to be tight enough in the closed position that the seat won't move, but not too tight to make opening it impossible. Adjust by dialing the bolt tighter and putting the quick release back in the closed position. Try to rotate the seat to ensure there's no movement. This type of stem is a quill stem. A quill stem is secured in place by tightening the main bolt at the top, which tightens the components inside the steer tube. Slide the stem in place and make sure that the minimum insertion lines can't be seen. Once this is done, tighten the top bolt while keeping the bars positioned properly over the fork. This component needs to be very tight, and failure to do so could cause serious injury. This is a threadless stem, which has a bolt at the top called the stem bolt and 2 pinch bolts on the side. When the bikes are being shipped, they will sometimes place the stem upside down. Your stem should be set up with an upward angle. If your stem is flipped, loosen or remove the stem bolt and loosen off the 2 pinch bolts on the side. You can then flip the stem and secure the stem bolt with light pressure. Start tightening this bolt with your fingers to avoid stripping it. Do not over-tighten the stem bolt, as this can cause damage to the components. Once it is secure, tighten the 2 stem bolts on the side and make sure that these are very tight and will not rotate. Next, remove the faceplate from the front of your stem so we can install the handlebars. These will either have 4 small bolts or 2 large bolts like the example shown here. As you do this, make sure the cables are not tangled. Your handlebars need to be centered in your stem and shouldn't be able to see the lines on the handlebars once the faceplate is reinstalled. Loosely reinstall the bolts with your fingers to ensure you don't strip them. Rotate your handlebars so they sit in a natural position and secure them slowly, tightening each bolt. For a 4-bolt faceplate, tighten in an X pattern. For a quill stem, you may have one large bolt that needs to be secured with a 13mm wrench. Use the quick release axle to install the front wheel, which is made up of a dropout tab, a spring on each side, another dropout tab, and a nut. Not all bikes have the dropout tabs, however. Remove the nut, dropout tab, and one spring, taking note of the order. Slide the skewer through the center hole of the wheel and reinstall the spring, tab, and nut. The narrower part of the spring needs to be on the side closest to the center of the wheel. Some bikes use large bolts instead of the quick release, so you need to ignore the previous step if this is the case. The next steps will be easier to complete with the bike placed upside down. The wheel is meant to rotate in a specific direction, and you can determine this by matching the direction of the front tread to the rear tread. The quick release needs to be loose enough that you can place your axle into the dropouts on the front fork. If your quick release has dropout tabs, you will see 2 small holes on your fork, and this is where the dropout tabs would sit. With your quick release lever in the open position, tighten the nut until snug, and place the lever into the closed position. You should be able to close the lever with only minimal resistance, but it should require some force to open when fully closed. Let's install the pedals. There's a left and a right pedal. You can tell the difference looking at the end of the threads where an L or R is labeled. The L pedal will go on the left side of the bike and is reverse threaded, so you will thread these counterclockwise to install. The R pedal will go on the right side and threads clockwise. If you have grease available, put a small amount on each pedal's threads. Hand thread both on as far as you can. If it is not going in straight or is met with resistance, double check that the right pedal is going onto the right side. Using your 15mm wrench, tighten the pedal by grabbing the opposite pedal or crank arm and rotating until secured. This might be a difficult step without a pedal wrench, and you may have to find a thin 15mm wrench to complete this task. Next, let's inflate the tires. You can locate the recommended tire pressure and PSI on the side of the tire. Tire pressure is something that should be checked often to make sure you are not riding on a deflated tire and potentially damaging your rim. Inflate both tires to their recommended pressure and install the dust caps once completed. Let's flip the bike back over to set up the brakes. If you have a second person, have them hold and stabilize the bike, or lean your tire against the wall for the next few steps. This demonstration is for V-brakes, which use rubber pads to clamp down on the rim. We've removed the tire to help show the adjustment, but you will not need to do this when setting up your own brakes. First thing we're going to do is adjust the brake pads. As you can see, the brake arm on the left of the screen is flush with the rim and maximizes the amount of contact it has with the rim. The right brake pad is too high and needs to be adjusted to match the other pad. A poorly adjusted brake pad can result in brake failure, so make sure the pad is flush with the rim and is positioned properly. Loosen the pad a few turns so that the pad is loose and can be adjusted. Push the brake arms towards the rim to imitate engaging the brake. Align the pad so it is even with a very little gap at the back to prevent the brake from squealing. Wiggle the brake so that it sits securely in position and start slowly tightening the pad. When it is no longer loose, release the brake arm and tighten the brake pads all the way while holding it to prevent from rotating. Once it's secure, check to make sure the pad is correctly aligned and is clamping properly onto the rim. We now need to install the brake cable into the brake lever by sliding the cable through the gap under the lever between the two slots on the barrel adjuster. Once you've done that, screw your barrel adjusters all the way in and make sure that the slots aren't aligned. Connect the brake line with the brake arms by inserting the silver noodle into the metal guide on the left brake arm, making sure it securely sits in place. Make sure the noodle is secured in place or the brake may not engage safely. You will see that you now need to adjust the cable tension on the brakes. Too little tension will result in the brake pads not making enough contact with the rim when you engage the lever. Slightly loosen the brake cable by loosening the bolt about 1 full turn. Do not completely undo this bolt as it can be difficult to reset. Pull the cable to increase the amount of tension on the brake, reducing the slack in the cable. If you accidentally pull the cable too tight, the brakes rub on the rim and will not function. A small amount of rubbing on one side is okay, because we can adjust for that in the next few steps. Pull the cable fully tight, then give it about 1 centimeter of slack and retighten the bolt. Do not over tighten this, but ensure it is tight enough for the brake cable to not slip through the nut. Your goal is to adjust the tension so your brake lever is clamping parallel to the handlebars when you squeeze it. Now that your tension is good, let's make sure that both brake arms are pulling equally. Use a number 2 Phillips screwdriver and the screw on the bottom of your brake arm to make this adjustment. Slightly tightening the screw will load extra tension on your brake arm springs, making the pad pull away from the rim. Loosening the screw slightly will move the pad closer to the rim. For this brake arm, we need to tighten the right side and loosen the left. Notice that it only takes a few small rotations on each side to correct the issues and get the pads pulling equally. Squeeze your brakes in between adjustments to reset and repeat with your rear brake. This is a disc brake that uses a cable to operate. When you squeeze the lever, the cable pulls the brake arm, which causes a metal rotor to be squeezed between 2 brake pads. One of the pads moves while the other stays stationary. We will start by securing the caliper by tightening the bolts that connect to the fork. Then, we will make sure the caliper body is lined up, straight, and tighten the bolts to secure the caliper positioning. You want to have an equal gap between both sides of the rotor and the brake pads. Then, tighten the bolt to secure the cable. Slowly dial the stationary pad inward. Continue to do this until there is very minimal contact between the rotor and the brake pads. Dial the pad out a 1/4 turn and check to make sure there is no contact between the rotor and the pads. Then, move to the other side with the rotating arm and adjust the barrel adjuster. Dial it out to add tension to the cable or dial it in to give it more slack. You may have to adjust the cable tension using the bolt if this is very far off. As with all brakes, your brake lever should be parallel to the bar when you squeeze the brake. Cut and cap the cable to 1 inch to avoid having cable wrap up in the rotor. A cable cap is provided in your accessory box. This is a hydraulic disc brake that uses fluids and pistons to squeeze a rotor between 2 brake pads. These brake pads do not have a cable, and both brake pads will move equally when engaging the brake lever. Loosen the 2 bolts that secure the brake caliper, wiggle the caliper, and rotate the wheel. Engage your brake and stop the wheel, then gently wiggle the wheel. This will center the brake pads along the rotor and create an equal gap between the rotor and both the brake pads. Tighten the caliper body and test the brake to make sure there is no rubbing. Do not over tighten this bolt as it can be easily stripped. Disc brakes can be quite complicated, so reach out if you have any issues. For this next section, we will be adjusting your derailleurs and you will need the help of a second person to hold the rear tire off the ground, or you can make a makeshift bike holder. There are 2 types of shifters, a grip shifter or a trigger style shifter. This is a grip shift, but they both function the same, so don't worry if your shifter doesn't look like this one. While pedaling with your hand, slowly shift through the gears. Your shifter causes the derailleur to move on the bike, which moves your chain and shifts into different gears. The shifter on the rider's right side controls the rear derailleur, and the shifter on the left controls the front gears. Now, let's start making some of our adjustments. Start by making sure your derailleur is properly secured to the bike frame and your cable is also tight. It's important that you don't over-tighten the bolts, pinching the cables, as this can cause fraying. We are then going to adjust the limiting screws, which stop the derailleur from pushing your chain into your spokes or off the gears the other way. On the back gears, the smallest ring is your high gear, and the limiting screw that controls this gear is labeled H. The biggest ring is your lowest gear, and the corresponding limit screw is marked with an L. Set the derailleur in the highest gear, which is your smallest ring. Adjust the screw to align the cogs so that the gears are aligned on top of each other, creating a straight line. If the H screw is too tight, you won't be able to shift to the bottom gear, but if it's too loose and allows for too much outward movement, your chain could slip off. Continue adjusting until centered over your smallest ring. When using your limit screws, it's a good idea to only make small adjustments, like a quarter turn at a time. While pedaling, move your chain to your biggest ring or your lowest gear and gently push the derailleur with your finger. This will make sure you are testing the full range of the derailleur's limits. We are going to do the same thing and set our L limit screw to make sure the chain can't go past this gear and into the spokes. Moving the screw clockwise will move the derailleur away from the wheel, and loosen the screw will bring it towards the wheel. Since the derailleur is too close to the spokes, we will tighten the screw and restrict the derailleur from swinging as far. Once we have made this adjustment, the cogs will be lined over top of each other, and this adjustment will be done for our limiting screws. Now that we have set the range your derailleur can move, we need to make sure that it shifts smoothly through all of the gears. Start in your highest gear while pedaling and shift through each gear one at a time. As you change gears, your chain should move to the next ring as close to unison as possible. If you change gears and this doesn't happen, you may need to correct this with an adjustment. If the chain struggles to move up a gear but easily shifts down a gear, you may need more tension on your cable. If your chain quickly jumps up gears but often hooks on the next gear, causing excessive noise, or it struggles to go down gears, then your tension might be too high. If your tension is low, spin the barrel adjuster out by rotating it counterclockwise. If your chain tension is high, reduce tension by dialing the barrel adjuster inwards or clockwise. Continue adjusting until you can move your derailleur into every gear smoothly. This might take some time, so be patient and make small adjustments along the way. Some bikes will also have a front derailleur, which operates similar to the rear derailleur. Start by securing your front derailleur and tightening the clamp bolt. The front derailleur also has limiting screws which work in a similar way to the rear derailleur, except that they are reversed. The H limit screw controls the large cog, and the L limit screw controls the smaller cog. Let's start with setting up the L limit screw. While pedaling, place the rear derailleur into the biggest ring and the front derailleur into the smallest ring. While still pedaling, move the L screw in until you hear it rubbing on the derailleur, then slowly move the screw out until you no longer hear it rubbing. Then, change into the second gear, then back down, and it should move smooth with no rubbing, and the chain shouldn't fall off the bike. If it does fall off, reset the chain and slightly tighten the L screw. The low limit screw should now be set, so let's move on to the high limit screw. Move the front so that it is now in the biggest ring. Rotate the H screw out a couple of turns, and move the H screw until there's approximately a 1 mm gap in between the chain and the arm of the derailleur. Keep the front derailleur in the same position, shifting through all of the gears on the back of the bike to make sure there is no rubbing on the front derailleur. You may have to make some small adjustments until it stops rubbing in the largest cog. Now, we need to adjust the tension, known as indexing. You'd need to adjust the cable tension so that the derailleur shifts smoothly and you don't get any rubbing. Shift your derailleur from your smallest gear to the largest gear. If it struggles to get up to the next gear, add a little bit of tension to the cable. If the gear moves up fine, but does not shift smoothly down, then reduce the amount of tension on the cable. Test out the gears running through every one of the gears, making sure that it shifts up and shifts down smoothly. At this point, all of the gears should be adjusted, so please reach out if you have any concerns. We are approaching the end of the bike build and need to verify that every bolt and component is secured. Go through and check every component and tighten all of the axles, brake pads, brake arms, derailleurs, crank bolts, pedals, stem components, handlebars, and any other components as identified in your owner's manual. Also, take the time to install any other accessories, including your front reflector on the handlebars. Finally, we can make a few small adjustments to the brake levers to ensure they are fit for the rider. Have the rider sit on the bike and extend their arm grabbing onto the brake. Adjust the lever so that the wrist is straight when they are in the riding position, and then begin to tighten the brake levers. Do not over tighten these components as they can easily be broken. Then, adjust the saddle height to make the ride more comfortable for the rider, noting that they should just have a slight bend in the knee when they are seated and the pedal is at its lowest point. Confirm that the minimum insertion line is not showing during any adjustments of the seat. You made it! If you've executed the appropriate steps from the video, you will have a properly built bike that is safe to ride. It's always important to follow proper storage and maintenance procedures on your bike to keep it running smooth and safe. If you're still not sure if something went right in the build or you have any questions at all, please reach out to our customer service team and we'll be happy to assist you further. Thanks for watching. Until next time, be safe and have fun.